Okay, since our classes are different this year, I'm going to split the laws of exponents up into 2 different weeks. So negative exponents will be next week. They're a little bit tricky for kids, and I want you to have a week with this material before we go on to negative exponents. So we'll be doing factoring after this. So it's a little bit different than I normally do. So first, what do you do when you multiply two things same base? Remember, a power is the number of bases that are being multiplied together. So if you have the same variable, it'd be x to the m plus n. You add them. So if I have x to the 6 times x to the 4th, you're really saying I have 6 x's and I want to multiply 4 more together. So I'm putting them all together. So all together you would have 10 x's multiplied together. So if I have x to the 17th times x to the 4th, that would be, 17 of them, 4 more of them, so altogether you have 21 of them. So if I said x to the 6th, y to the 10th, and I want to multiply that to x to the 4th times y to the 11th, you're multiplying. That's what it means when you have two parentheses next to each other. So that would be x to the 6th times x to the 4th is x to the 10th. And y to the 10th times y to the 11th would be y to the 21st. Oh, mercy. And that's my answer. That's a monomial. Then if I have something raised to a power and I'm raising it to another power, well, that would be x to the 4th to the 3rd. Well, that means you have 3 of these multiplied together. That's what that means. You have 3 of them. Well, when you multiply things together, same variable, you add the powers. 4 plus 4 plus 4 is 12. So the rule is, when you have something to a power, then you raise it all to another power, you multiply the powers. And I am getting sloppy. So if I said what's x to the 6th to the 10th, you could write out 10x to the 6's and use the first rule. Or you could say when you have a base raised to a power to another power, you multiply the powers. Now this one, 3 and 4 are really the same. What if you have a fraction or a product raised to a power? Well, you raise everything in there by that power. So it'd be x to the m, y to the m. So if I said 2/5 squared, since it's all in parentheses, you'd have 2 squared, 5 squared, which is 4 over 25. So if I said x to the 6th, y to the 3rd, and I'm raising it to the power, then you raise it all, so it'd be x to the 3rd, x to the 6th to the 3rd, y to the 3rd to the 3rd, so it'd be x to the 18th, y to the 9th. Same thing with a product. If you have a product raised to a power, now notice a product, not a sum. Sum is different. So you just raise both to that power. So if I have 2x to the 3rd power, you'd say it's 2 cubed, x cubed. And 2 cubed is 8. So if I have x to the 6th, y to the 10th, and I want to raise it to the 4th power, I raise both to the 4th power. So x to the 6th to the 4th would be x to the 24th, because when you raise a base to a power to another power, you multiply. Y to the 10th to the 4th would be y to the 40th. And the last one we're going to do in this video is what do you do when you're dividing where there's actually 3 parts. So if the powers are the same, then the answer is 1. Oops. I have written this very sloppy. Let's do this. If m equals n, b, if the power on top is bigger, then you have more x's on top, so you subtract and leave it on the top. If you have x to the m, x to the n, and the bottom power is bigger, then it stays on the bottom because that means you have more x's on the bottom. So if we have x to the 4th over x squared, that means you have 4 x's here, you have 2 x's here. 2 of the x's cancel out with top and the bottom, reduces out. So therefore it'd be x to the 4 minus 2, which is x squared. Or if I had x to the 6th over x to the 10th, 6 x's cancel here, 6 cancel here because those are in common in both. So it would be 1 over x to the 4th. You go 10 minus 6, it stays on the bottom because the bottom power is bigger. Now we're going to do some practice in the next video.